Right, so these are some samples of the momentum and impulse concept builders that I'm going to ask you to do in class. Keeping that in mind, uh, when you go into the physics classroom, the key thing you got to do is log into your account. If you can't log into your account, you need to get a password reset. You should be able to do that on your own, or I can ask you that. Most people use their Bishop Hartley email. I think almost everybody did that. The password was something you chose. Okay. Um, at any rate, when you click on that, you're going to go down and see classes down here, and I should be the only class you have that uses this. And then there's going to be assignments, some of which are in the past, some of which are coming up. So, of the three concept builders, the first one is case studies, impulse, and force. I've asked you to do the wizard level for full credit, or you could do the master level for less. It loads like this. You know you're logged in when your email gets shown like that. So I'm going to go to the wizard level and do an example. Remember, you always can do the help menu, and you can always read directions. So sometimes the help menu is helpful, sometimes it's not, but usually it is pretty well. There's also parts on the physics classroom tutorial on momentum as well. I think I put a link to that earlier, which can help you with your understanding as well. So I'm going to get out of the help menu. I'm going to go back here and look at this example. So you want to read these carefully. Compare the collision between two balls in the floor. Happy ball collides with the floor moving at 2 meters per second and rebounds at 1 meter per second. Case B, a sad ball with the same mass collides with the floor at 2 meters per second and stops. The collision time is the same for each case. So which variable is different? You toggle through these. So it's going to be delta V, which is the change of velocity, the time, and the mass. Well, it says they have the same mass, so it can't be that. Delta V, I think that is different because this one's going down and then bounces up. This one's going down and just stays there. Time is the same because it says the collision time is the same for each case. So delta V is the one I want. Which case involves the greatest momentum change? Well, you might think this does because things are completely stopped, but in this particular case, it's going down and then back up. That's a greater change in velocity. For example, this is a change of velocity of 3 meters per second. This is a change of velocity of only 2 meters per second. So that's going to be case A. Once you think pretty carefully and get the greatest momentum change, the impulse change will always be the same because by definition, impulse is a change in momentum. So in this case, which involves the biggest force, well, if you remember your general equations, Ft equals m delta V. If the time is the same, the delta V is bigger for A, and masses are the same, so then we're going to have the greatest force in A as well. So data away. Remember, if you get one of these wrong, it'll, instead of getting a star, you'll show up as red here, and then you have to do two different, be successful twice in that particular one to get a star. I'm not going to go through this one completely, but I do want you to think about it. So case A, a gymnast strikes the floor at 12 meters per second with relatively stiff knees. She comes to a stop. Apparently she's bald. Same gymnast strikes the floor at the speed of 12 meters per second with relaxed knees and some bending. So essentially what's going to happen there is because the knees are going to give, it's going to take more time for the person to come to a stop. The same initial velocity, so the same final velocity, so the momentum change would be the same. But since the time is going to be greater for case B, the force is greater for case A. So that makes sense, like you feel more force if you're going stiff-legged into something than if you bend your knees. Okay. All right. The second one is going to be law enforcement explosions. So in this case, I'm giving you some options of doing master, wizard, or apprentice, master, or wizard level. You only have to do one level, but it may help you to do an easier level first and then go from there. So explosions. Yep. So I'm going to do a wizard. Hopefully I get these right. I haven't looked at these in a while. So in this case, two spring-loaded carts at rest on a low-friction track. The spring is released, pushing the carts away from each other. Three situations are shown. Identify any situation that violates the law of momentum conservation. So note the bricks on top of the carts have the same mass as the cart. Arrows represent the velocity of the cart. So for example, this blue cart has a mass of 2, the red one has a mass of 1. Here, this arrow is twice as long as this one, so that says it's twice the speed of this one. So in this case, we have 0 momentum before the collision, so we should have the same amount leftward after the collision as we have rightward. So this is 2 masses times 1 velocity, 1 mass times 2 velocities. I think that's legal, so I think we're good. In this case, this has 1 mass and this is 3 units of mass, so this should be moving 3 times as fast as this, and it's not. 1 mass times 3 units of velocity is 3 to the left. 3 units of mass times 2 of velocity is 6 to the right. So that is not allowed. So they are in jail, physics jail. So in this case, this has 3 units of mass and 2 units of velocity. So my bet is that this should be going at 3 units of mass, 2 units of mass. This should be going slower than this one, and it should be going 2/3 the speed of this one. This says it's going 1 unit of velocity, and this is 2. So that is still violating the law of conservation of momentum. Why? Because we've got 3 masses times 1 velocity, that's 3 units of momentum to the left. 2 units of mass times 2 velocity, that's 4 to the right. That does not balance out with the 0 I started with. So I'm going to say that is illegal also. Okay. Another one here. Again, this is 1/3 the mass, should be going 3 times the speed. It's not. This is 3 masses and 2 masses. This is what we saw last time, because this should be going 2 speeds and this should be going with 3 units of speed, so that's not right. And this is 1 and 2, so that's 2 and 1. That's correct. Sometimes there'll be 2 jailbreakers and sometimes there'll be 1. So I think that's good enough for there. The last concept builder is law enforcement hit and stick collisions. So the idea here is that they are going to stick together, and again, momentum should be conserved before and after collisions. Once again, you're going to have a choice of apprentice level, master level, and wizard level. If you find the wizard level too challenging at the beginning, start at an easier one. It's extra practice, doesn't hurt. And hey, if you get this one right and you don't complete the other one, you'll at least get some points. So in this particular case, a moving cart collides with a stationary cart. The carts stick together and move at this same speed, so they're stuck together. Situations are shown. Identify that violate the law of momentum conservation. Once again, you can go to help menu, you can go to directions. So I've got and the bricks on the top of the cart have the same mass as the cart. So I've got 2 units of mass here, 1, 2, 3, 4, 5 units of momentum. So 2 times 5 is 10 units of momentum to the right. This is at rest, so it's got 0 units of momentum. So afterwards, I should have a total of 10 units of momentum to the right. I've got 1, 2, 3, 4, 5 mass units times 2 velocity units. So that is 10 units of momentum to the right, so that's legal. Here I've got 1, 2, 3 masses times 3 velocity to the right. That's 9 units of momentum to the right. Afterwards, I've got 1, 2, 3, 4, 5 units moving times 2 units of velocity. That's 10 units of momentum to the right. So it's acting like I gain momentum. That is not allowed. This one, 1, 2, 3 times 2, that's 6 units of momentum to the right. 1, 2, 3, 4 units of mass times 3 is 12 units of momentum to the right, so that's way off. You certainly shouldn't be going faster with more mass than with less mass, so that's illegal also. I'll look at one other one here. So this is 1 mass times 4 units of momentum, or 4 units of velocity, that's 4 units of momentum. 2 units of mass times 2 is also 4 units of momentum, so that's good. 3 times 4 is 12 units of momentum to the right before the collision. 1, 2, 3, 4 units of mass times 3 units of velocity is 12 units of momentum afterwards. So this is okay also. So I'm betting this one's going to be illegal. 1, 2 units of mass times 4 units of velocity is 8 units before. And I've got 1, 2, 3, 4, 5, 6 times 1 is 6 afterwards. So that's illegal. I'm going to check my answers. And that is good. So hopefully this helps, and hopefully you can get through with these concepts.